So now we know how to export to SOLIDWORKS from SOLIDWORKS, which doesn't sound all that impressive. But what if we want to export over to, say, Rhino, for example? Well, usually there are a couple of formats that people frequently use for this. Let's start with what I think is the best one, and then we'll show another one that people use as well. I'll go to File, Save As, and we're going to save this time as a step file. Now, usually there are going to be two versions of step showing up here, step 203, step 214. Step 214 is simply the newer version of step. It won't work with a lot of older CAD systems, but if you're working with modern day CAD systems, 214 is the way to go. Now, step is probably the newest of the interchange formats, at least of the major ones that are used frequently in CAD. So it's definitely going to carry the most information about your assembly, and a lot of that is really useful stuff. So let's save our assembly step file out here. And no, I don't want suppressed components. And then I could hop over to Rhino. Now, when we import this into Rhino, there are a couple things you might notice right off the bat. First of all, it's sideways, right? Clearly, this is not right side up. Well, this is a funny thing about working in multiple different CAD systems. I want you to look down here at the bottom right-hand corner of our Rhino screen, and you'll see that the Z-axis points up, and the Y-axis points basically forward and backward toward the front and back of the object. Whereas in SOLIDWORKS, you'll notice that the Y-axis points up, and the Z-axis points forward and back. That's because SOLIDWORKS is known as a Y-up environment, whereas Rhino is a Z-up environment. And that comes from whether you're used to working in engineering versus architecture, really. Rhino comes out of the architecture world, where usually Z is up, whereas Rhino or SOLIDWORKS comes out of the product design world, where usually Y is up. It doesn't really matter. The point is, you're going to have to rotate things one way or another. We do have ways of dealing with that we can talk about in a future video. So if you're working really commonly between Rhino and SOLIDWORKS, usually what I do is actually just change SOLIDWORKS so that it becomes a Z-up environment. And that way, we'll be able to go back and forth without any trouble at all. But that's a whole different lesson. The other thing you may notice when you import geometry to Rhino is that it all comes in as one big chunk. Notice this is one big block of material. Now, if I hit the Explode button, you see that this breaks up into its individual constituent parts. The only issue is that when you think about this, essentially what Rhino has done is when it imported this step file, it's grouped together the various sub-assemblies within our part. So, for example, look at this. The cameras are one big subassembly because in SOLIDWORKS, this is the head subassembly. Now, if I take that and I explode it, we'll be left with 3 block instances now. One for this guy, one for the camera right here, and one for the other camera. And then I can explode the camera and we'll get our individual parts. So those come in separately now. Then I can take those individual parts, explode those, and I'll be left with just a poly surface instead of a block instance, and then I can explode that, and then I end up with my individual surface bodies. Okay, so when we bring in a step file into Rhino, we're going to get lots of kind of layers of block instance groups, which actually is a really nice, clean thing, but just be aware of it. Another way that we can export from SOLIDWORKS to Rhino is using a different format. This one's really common as well, even though it's a little bit older. We're going to save, instead of a step file this time, we'll save an IGES file, IGS. Now, for some reason, I'm not seeing, there it is, IGES. Now, if I just click that and save this out, no, I don't want suppressed components. It's going to take a little bit longer to save this out. It's an older format. It doesn't carry as much information with it, and sometimes people really like that. So if I select this and delete it, this will go File, Import, and this time instead of a step file, we'll bring in that IGES file. Let's find IGS, open that up. It's going to take a little bit longer to import this, and it's going to process all of these bodies and bring them in, and this time it's going to forget a whole lot of information as it goes through, including all of those solid bodies. So remember how all those solid bodies came in grouped really nicely, so it was easy to get to them? With IGES, everything's going to come in as a separate individual surface. Sometimes you might want that, but usually that's kind of a disadvantage of working with IGES. Okay, so those are generally the two ways that you would go back and forth between Rhino and SolidWorks. Now, one other thing to keep in mind is that we can actually save out step or IGES files from Rhino and open them up in SolidWorks for a round trip. But also, SolidWorks opens 3DM files. You can actually open native Rhino files right here in SolidWorks. So round tripping between these two pieces of software works really pretty well. So now, if you're saving out to another CAD system, not Rhino, let's say you're saving out to Inventor or Creo, these ones you're going to save out a step file, typically. You can save an IGES file, they'll open that as well, but it comes with some of the same kinds of disadvantages. Typically, step is the way to go. Now, there's one exception to that rule, and that's Unigraphics NX. UGNX is actually on the Parasolid kernel as well. In fact, SolidWorks licenses the Parasolid kernel from Siemens in order to use it in SolidWorks. So if you save out a Parasolid file, you can open that in NX beautifully. So I highly recommend, if you're exporting between SolidWorks and NX, you definitely want to use those Parasolid formats. All right, so let's actually move on to something a little bit more interesting.